Okay, circles part 7, writing in standard form. Here I've got a mess of a whole bunch of stuff, but here's the key detail. X squared and y squared, okay? And if I were to move this over so they were on the same side, they'd both be positive. Same coefficient, both positive, I've got an equation of a circle. Now standard form is what we referred to on the last page, and it looked like this. X minus h squared, y minus k squared equals r squared. So my goal is to make it look like this. And I'm not 100% sure, so I'm going to do this first. I'm going to move this y over so I've got my x's, squareds, and everything's kind of in order. So by adding my y squared over, I end up with the following. I now have x squared plus 6x plus y squared minus 8y equals 75. Okay? Now when I'm looking at this, I'm hoping you recognize a pattern. If I cover up these parts for y, and I think about making a problem look like this, where I've got squares on both sides, I hope this is ringing a bell for maybe complete the square. And that's what we're going to do. All that changes from our parabola problems to our circle problem is now I need to complete the square twice, one for each variable. So let's go through that process. So right here, I've got x squared plus 6x. 6 divided by 2 is 3. 3 squared is 9, so I need to put a plus 9. Now whatever I do to one side, I do to the other, plus 9. Now, some of you are thinking back and was like, wait, didn't we add and subtract? Why are we adding twice now? It has to do with the equality. When we added and subtracted before, here's a little aside, we had the equation of a parabola where when we came to this and said, hey, in order to get this first part in parentheses to factor nicely, I need to put a plus 9, I couldn't add 9 to the other side because I wanted to leave y by itself. Since it was on the same side as our equal sign, if I add 9, I have to subtract 9. And so that's why we had the plus 9 minus 9, because they were on the same side of the equality. But over here, I can do stuff to both sides of the equality. So I might as well do the same thing to both sides. Algebra 101. Plus 9, keep it balanced, add 9. Okay? Now, that means that if I added 9 there, I can take this right here. Negative 8 over 2 is a negative 4. Negative 4 squared is a 16. So in order to balance out the y's, I need to add a 16 to both sides. Oop, 16, not 6. Okay, so here's what I'm going to do. X squared plus 6x plus 9 factors into x plus 3 squared. Y squared minus 8y plus 16 factors into y minus 4 squared. And if I add 75, 9, and 16, I get 100. You may also choose to write that as x plus 3 squared plus y minus 4 squared equals 10 squared. Again, I'm not picky about either one of those for our purposes. You just need to be able to interpret either case. So that means if I had this problem, I know that it would have center. Remember the inside is opposite. So negative 3, positive 4, and a radius of 10. So while it looks kind of complicated at first, it really is just as simple as complete the square twice, one for each variable. That's all you got to do.